That's not a good look, Barry.
You're out of focus.
That's the story of my life.
There we go. Yes,
It's
no.
an AI controlling the focus?
Yes.
He doesn't like it, Frank.
What the hell?
Talk about AI so much that he doesn't like
Yeah, I
it.
know, it's turning against you.
I was trashing AI. It's like, it hallucinates too much. You know, reasoning models hallucinate 1/3 of the time. That's.
And people are just
That's only a
blindly
little-
still.
I know, and that's the basis of all agents.
Yeah.
Okay.
Suddenly it's not focusing.
Come closer.
It hasn't happened. There you are. That's good.
Oh, right here. Okay. I'll stay here then.
And go to it.
Action.
All right. Lights. Everybody quiet on the set. Roll up.
Hi, everybody. Welcome to the July New York JavaSIG meeting. And thankfully, it's not raining, so that's a good thing. And tonight we have Billy Korando from Oracle talking about Project Leyden, which certainly is speeding up JVM startup, which is obviously good for microservices. And as I was thinking about it, it's really good for agents because they're basically microservices, right? So that's a good thing. I know we have restricted time here. We only have an hour, so hopefully that's good.
So 7:30?
7:30, yes. Okay. So with that, let me turn everything over to Billy.
All right. Thank you, Frank. Everyone on the live stream. So yeah, thank you, Frank, and thank you, New York JavaSIG, for hosting me today. With that said, with only about an hour, I'll go ahead and get started. So my name is Billy Korando, Java developer advocate with a little company called Oracle, but don't hold that against me. And we're going to be talking about lightning in a jar, or how to improve startup and warm up without sacrificing Java's dynamism. So important information. Yeah, feel free to ask questions. Usually this talk has been going around 45 minutes, so we should have plenty of time for Q&A, even kind of during the presentation. And of course, please, feel free to ask questions. I'm here for you to learn about Project Leyden or, of course, anything Java related. And if you go to this link here, you can actually get to this very presentation right now. And feel free to email me at billy.korando@oracle.com if you have any questions after this presentation. If you'd like to know more, we have some other great locations to go to, sources to go to. Dev.java, which a few people already in here know about, but that provides tutorials on various Java subjects. We also have the Java Playground, which is a way you can play with new Java features, language features, not like Leyden really, in the browser without having to download and install the JDK. And also how to find various other jugs around the world even. Then there's also insight.java. That's where we kind of publish, like the JDK engineers, they'll publish any kind of articles their bloggers are working on maybe new features, including Leyden or Valhalla and all that. So that's a good place to kind of see more of the bleeding edge of what's happening within the JDK. And then there's also our YouTube channel as well, and Insight Java podcast. So how many people here are on Java 17? A few. How about JDK 21? A few more. So is anyone still on JDK 8?
I should raise my hand.
No, I'm actually glad to see it. It's not so many people like that. It's I just remember 2 years ago when I was doing Jug visits, I would ask the same question, and about half of everyone would raise their hand to Java 8. It was definitely the majority or close to it. Then last year, it became primarily JDK 17. And so it's good to see that people are actually moving forward and upgrading. I know it's a difficult process. That said, though, with our YouTube channel, with JDK 25 coming out here, which obviously has LTS support, we're also going to do a series of videos that cover all the major changes and how to upgrade from JDK 21 to 25. So if your organization is looking to be upgrading to JDK 25 pretty soon, definitely check out those videos. I think it's going to be 5 or 6 videos where we kind of cover the important changes between 21 and 25. All right, so for the agenda, we're going to go through 4 kind of major items. The first one, we'll just kind of give an overall view of Project Leyden or Leyden. again, it's a Dutch word, which we'll touch on in a moment. I mean, come on, you guys knew Amsterdam, right? Oh wait, that's older, but you should know better. Then we're going to get over a little bit of like time shifting work, training runs, and then a little bit into the road ahead for Leyden. So the name, so OpenJDK, as they're developing new features, if there's like a somewhat substantial thing that's not going to be all released, maybe as like a single new change, they often develop under projects. So like other existing projects could be like Project Loom, that's where like virtual threads and the new concurrency models being developed out of. There's also like Project Amber, so like all like new records, pattern matching. A lot of the new Java language features are all being done under Project Amber. And then there's also, for example, here, Project Leyden. And so the name of it, or where that name comes from, is called a Leyden jar. And it was developed in the city of Leyden in the Netherlands. But it stored an electrical charge. So within a jar, you know, jars like Java, get it? Electric, fast, yeah. Also, fun fact, the Leyden jar was the first capacitor. There's three major goals with Project Leyden. The first is to reduce startup time, and the way the Leyden team generally kind of describes what they think about that is a time until the first useful work. So, for example, like Frank, you're mentioning like microservices, which obviously would have a lot of relationship here with improving startup time. The time to first useful work would be when the liveness probe for your microservice says it's the status is up or it's ready to start processing. So it's not just about getting to the main method, it's about actually that application being up and ready. Then there's also reducing the warm-up time. So of course, once your application is up and running, it's not necessarily going to be at its peak throughput. The JDK or the JVM has the JIT, the just-in-time compiler, and what it can do is it can profile what the application is doing to see what are the parts of the code that are being the most utilized, maybe what kind of paths the code is taking, and then optimize that code. So the JVM that you're all likely using is the hotspot JVM. The hotspot is derived from the fact that the JVM will actually look to see for the hot points within your code and then to optimize that. So that's actually where the name hotspot comes from. The final goal is to reduce the footprint, that is reducing the memory usage of the application. I guess two caveats. One, that it's not currently a priority of the Leyden team. So that's going to be something that, you know, might be a little ways off. And then of course there will be a trade-off when it comes to increased disk space. That the way Leyden works is by creating an AOT cache that the JVM will read from, which we'll get to in a few moments. But, you know, in order to save memory by not having to do all this processing, it's going to be all stored within this cache. So you'll have to trade off between saying like, okay, do we want to use up additional disk space to save some memory? Many organizations, many teams, many developers will probably make that trade because disk space is extremely cheap, but it's, of course, something to think about whenever that kind of eventually gets to that point. So whenever your application starts up, a lot of stuff happens. So at the application level, you know, your application is going to be reading configuration files. It's going to be scanning for annotations. You're going to be opening sockets to, you know, databases or other external services and registering listeners. Also, a very popular thing would be creating loggers. At the JVM level, you're going to be doing things like class loading, linking, and initialization. The JVM is going to be looking up those classes from the disk as well, potentially. Just doing validation of those classes, running your class or static initializers. Then it's going to be interpreting the code, calls like linkages, all this stuff. So it's a lot of work happens at startup time or for profile gathering during that warm-up phase as well. And so this is going to happen every time an application starts up. It becomes like a bit of a somewhat Sisyphean task for the JVM that, you know, 99% of the time when you're starting up a given application, you know, it's going to be a pretty similar task. I mean, the only time there's probably going to be particular variance is maybe a little bit in the warm-up phase. Maybe that doesn't always run the same depending upon the actual load of the application. But otherwise, all the other stuff of like the class loading, reading config files, scanning annotations, and so on, well, that's going to be almost the exact same every time, at least for a given version of the application. Obviously, if you update your code, that's going to change. But otherwise, the JVM, when you're killing an instance or you're starting up a new instance, having to go through all that again is a whole bunch of work to do. So the way of doing this is by, quote unquote, time shifting your work. To achieve the goals of reducing startup and warm up, it's not that it can be not done. Like, this work would still need to be done. You would still need to do class loading and linking, and calling class initialization and all that. So what the Leyden team is proposing to do is time shift that work from doing it during the runtime phase to the kind of the build phase of the overall kind of application process of your application, your build pipeline, that is. And then recording kind of what is happening, and then taking that behavior and then storing it in the cache, from which it can be then read later at subsequent startups of that application. So far, there's been one shipped feature from Project Leyden that came out in JDK 24, and that was the ahead of time class loading and linking. As far as upcoming features here in JDK 25, one of them is an ahead of time command line ergonomics, which I'll get to here in just a moment. And then the other is the ahead of time method profiling. So yeah, as I just covered just a few moments ago. So yeah, what's in the cache? So this AOT cache that we're building, what are we going to actually be storing within it? As I mentioned before, kind of like all the work that's happening, that reading the config files, scanning, and all that stuff. Right now, that isn't quite a goal or priority for the Leyden team, because that's getting into user code, and there's a lot of potential for things to potentially go wrong with that. The goal is to maybe eventually get into some of those areas. But right now, a lot of the work, I thought I updated this slide, is happening at the JVM level. So like right now, as I just mentioned, with like the ship feature of ahead of time class loading and linking, so we're handling class loading and linking in the AOT cache. We're not doing initialization yet. That might still be sometime down the road. So I thought I updated that to not have that bold anymore. But yeah, it's only class loading and linking. There's also the reading of classes from disk, storing that in a cache. That's actually a vestige from the feature that Leyden is being built on top of CDS. Who here has heard of the CDS feature? One per, you don't totally get, but yeah. But it's always kind of like that. Like almost no matter the size of the room, there's always going to be like one person. It's like if there's two people in here, like one person still would have raised their hand that they knew about CDS. So what CDS is, initially it was called class data sharing, then it became code cached data storage, but that all goes away. It's all being superseded now with AOT. It actually goes back to the JDK 5 days. And so back in JDK, or whenever the JVM starts up and the class loading, the first part of that class loading is it needs to find the actual binary representation of that class out on the file system. So back in JDK 5, 2004, I believe is when that came out, most of the file I/O that was happening off of old hard drives, the magnetic spinning disk. So back then, file I/O was much more expensive than the solid state drives that we had. And so to address the issues with startup at the time, the JDK team, particularly on Windows machines, developed a cache data sharing to where you can have a pre-processed cache of like all the classes that the JVM was using at startup, and you can just load from that cache instead of actually having to find the representation of it. You could also do other things, like you had multiple JVMs running on the same system. It would all memory map to the same location, but that doesn't work anymore because that represented a security vulnerability. Also, another thing it would do is also that all those class files would be already validated. So it would save some startup. So that's kind of like the foundation on which this AOT and Project Leyden is being built upon. And then again, there's like also class linkage and constant pool resolution and profile gathering. So yeah, let's look a little bit of kind of what I'm talking about with the class style and linkage and constant pool resolution and all that fun. So yeah, I've kind of been working on like a really just trivial application. This is little more than hello world, but kind of what's happening here is I have a loop that I can pass in just to run an arbitrary number of iterations. And then within that loop, it's calling two different methods, foo, which simply adds two values together or adds two values based on the iterations it's going through, and then bar, which will then multiply the values, but then it's being only executed once every 100 iterations. So let's see, yeah, Java P. So when you run JavaSIG on your Java class, what it produces is the bytecode for the class. And you can see within here, this is what the bytecode looks like, which there's obviously, even for a very simple class, you can see that a lot of bytecode is generated. But for example, there's things like the constant pool. And so like this does like a method reference, and it's saying, okay, it's referencing here the Java Lang object. This is the constructor for the Java Lang object. And so initially, this is just giving instructions to the JVM on where all these things reside. And when the JVM first actually reads in this class, it needs to then resolve all these different constant pool references, which obviously takes a bit of time. So some of what AOT Leyden is doing is when the JVM starts up, it can record all these resolutions and then actually store it for a later time, so it doesn't have to do it again when it starts up. So this is kind of demonstrate this like a bunch of bytecode that's happening within here. And AOT, instead of it having to do all these resolutions, we can store it for then subsequent executions of the application. But yeah, so also another thing is then the JIT process of it. So here, if I was to run this 4,000, oh, 5, yeah, there we go. I just wasn't on the correct Java. Is the text all big enough, or do I need to increase? Okay, perfect. I should have asked that earlier. So here, what this is doing is I'm executing the program, and then this command of compile command will kind of print out whenever the JIT tries to optimize the code. So as I run this iteration or this loop 10 times, that is not enough for the hotspot compiler to say like, okay, I need to optimize this code. If I was to run it 1,000 times, then we see that the foo method here is optimized to like tier 3 of the JIT optimizer. There. Uh-oh. Coming back? Oh.
There you go.
Okay, cool. To tier 3. So there's multiple tiers. There's tier 0 when it's just being interpreted. Then it usually goes to tier 3 for like some optimization. If I was to run this even more times, so then it could get up to tier 4 as well. If I did even more here, then it starts to optimize other parts of the application. So, but it kind of also gives you a little bit of the idea of whenever the JIT compiler, it's not just saying like, oh, this method is run a couple of times. Like it usually has to be run hundreds of times before it starts to optimize it. And so how that would actually then work in, like a real world setting typically is that, it would maybe take a few moments, a few seconds, or maybe a couple of minutes, kind of depending upon how much load your application is experiencing before the JVM would get a good idea of what code needs to be optimized, which code is going to be the most often used. Yeah, let's see. Oh, yeah. Well, I'll actually get into that a little bit later here once I actually get into the more advanced demo. So yeah, so what are the advantages of Leyden? Because there are other options out there when it comes to improving startups. So GraalVM is definitely the most well-known. And as far as if it's purely startup you're going for, GraalVM or the native image of GraalVM is, we're never going to be able to compare to that because it's actually creating a native binary. And so it can obviously start up then, within a few milliseconds. But there's sacrifices you have to make. You're not going to get the reflection. You're giving up the JIT for it. So, once you start up a native image, the throughput you're getting at that level is a throughput you're going to get for the entire lifecycle of that application. So, that is kind of giving up on some of Java's dynamism. Also, with Leyden, you're fully platform independent. There is Crack from the Azul team, but that depends upon the crew for Linux, which, granted, most of us are running Linux in production, so that's not too much of one. But if you are using other operating systems, that would be a disadvantage of that. And then also, you're not, so with Crack, like, you're taking a snapshot of the state of your application in a specific point, and then you're saving that to memory, and then you're going back to that very point. And if, like, the file system references were to change between when you take that snapshot and when you run it in another instance, then you could run into some issues. Finally, of course, as I mentioned, you still have full access to the JVM and the JIT to fall back on. You're not having to make any changes to your programming model in order to take advantage of Leyden. Now, maybe down in the future of Leyden, as we get more features added, as we maybe try to support things like class initializers, which again, we don't support right now, but it might be something that could be happening in the future. There might be certain things where, in order to actually take advantage of this class initialization, caching, that you would be limited to maybe some of the stuff you could do. But that's also stuff for a while from now, as the Leyden team works on that. They're definitely much more experienced in what isn't possible within that stuff. So Java is a statically typed language that when you're finding a variable, you give it a type. But still, despite that, Java is very dynamic. Dynamic typing with arrays, dynamic class loading. So a lot of frameworks like the Spring framework. So many of the frameworks that we use these days will dynamically load classes during the runtime of the application, or write classes and then load them in. As I mentioned with JITting, you have the dynamic compilation. Also, you can have decompilation. So, like, let's say you have some sort of a feature flag that you do by a property, and so maybe you have it initially set off at some point, and so when it hits that if statement within that feature flag, eventually the JIT will be like, oh, okay, this is always false, and you can maybe try inlining that if statement, but at some point maybe you update your application to enable that feature flag. Then, of course, obviously that optimization is no longer valid. So then, the JIT can actually decompile that code and then change it, and then eventually re-optimize it based upon that new criteria that then this feature, this if statement, is always going to be true, or whatever the switch that you made to it. So all that to say is there is a lot of dynamism within Java. It's static, but still a very dynamic language. That said, while we are preserving all the dynamism, we're not trying to make any sort of sacrifices with the programming model. There is no free lunch. So there is going to be some extra work, how to perform the training runs and where to store the cache. So building the cache, so right now, if you get JDK 24 and want to take advantage of the ahead of time class loading and linking, it's currently a 3-step process. The first process is where you would have to set the AOT mode to record, and then you would perform your training run. And then once that is completed, you would then need to run your application again with AOT mode and create. And once you kill that application again, then it would actually create the cache. Coming out in JDK 25, that command line ergonomics that I mentioned, that JEP, it's going to combine this into one single step to where the recording and the creation of the cache can all be done in a single runtime. The Leyden team was well aware that this was not ideal, so they improved it. There could still be some benefits to separating it out, because it could be some stuff saved in memory state that you wouldn't necessarily want to save to that cache. I think in most cases, you'll be fine to, or most times, the simplicity of being able to run it all in one step will outweigh maybe the slightly larger cache size. But there could just be, again, some occasional benefits to actually separating that out. But then, yeah, so we're running or this cache, so the question comes also then, how do you build that cache? And so I think there's like two particular ways of maybe attempting that within like your enterprise, real world setting. So one could be within your build pipeline that, to the right of this, you're doing the actual compiling and automated testing and all of that, the application. But then eventually, like once you get through all of that, then maybe you have some phase where you perform some sort of training run on the application. And what that training run constitutes, that's going to depend upon the needs of your organization. And we'll look at one example of doing a training run here in a moment, or actually a couple of different examples. And you can kind of start to get an idea of maybe what you would actually want to do with that. I would say one thing you probably wouldn't want to do is try to take a training run based upon your automated test suite. So there's two problems with using your automated test suite. One, it's not going to be really representative of the production load, because with the automated test suite, what you're really often doing is maybe checking each individual parts of the application just one time. You're not going through code hundreds of times. And so that's not going to give a good profile of what your application is actually going to be doing. The other issue with using your automated test suite is you have all your test classes, Mockito, JUnit, and all that stuff, and you don't want to be including that all within your cache. You're just going to be exploding the size of your cache, and then obviously as it's loading from it, that's just going to take it a little bit longer to load that cache in as well. So you probably don't want to do that. Maybe you feel like that's a good enough trade-off because you don't want the additional complexity. But at least, again, it's something to keep in mind that you wouldn't necessarily want to rely upon your automated test suite for building your cache. But yes, so within your build pipeline, one step of it could be involved running some sort of training run, and then killing an application, building the cache, and then possibly putting that cache within an image. Another option could be where you complete your full pipeline, and then you put your application out as a canary deployment. And once you validated your application and you think you got a representative example of production behavior, you kill it, and then you have it to where it's set up to then create the cache from that, and then you create new images based upon that, and then run those in production. Another thing could be also where's a cache. So I kind of already showed those examples of it. I think probably the common one is you're going to include that cache within the actual image you're making, just because that way all becomes one single binary and discrete and all that. Another potential option might be actually putting that on some sort of volume and then having your images reference that volume. The thing there is you would obviously want to make sure that the volume is going to be local or closely related, both in time and space, to wherever those images are running. You don't want to be like here in New York, oh, okay, yeah, our Kubernetes cluster, our container, whatever is here, but then where the volume, the AOT cache is located, it's actually in San Francisco, where it's on some servers there, because then, obviously you have a whole latency issue of calling literally across the country to then read that cache. So that would be at least one of the things you would definitely want to be conscious of. Any questions before I go into the second demo about Leyden features? Or okay. So for this part, the Spring Boot team, who's actually been kind of working with the Leyden team on this, not related to this directly, but they have their Spring Boot Technique application, and it's a simple demonstration application they use for demonstrating Spring Boot. How many people here use Spring Boot as our good amount? Yeah. Are people using anything else like Helidon, Micronauts, Orcus, or yeah. So yeah, Spring still kind of remains the rather dominant of them. Oh, yeah, not in the correct location.
I don't know if startup is here.
Oh, yeah. All right. Okay. Give me one moment to rebuild this. I thought. is it what, skip check style, I believe. Sorry, I must have accidentally deleted that jar file. Give me one moment to that.
So that was a good question to ask. Who else is using other than Spring Boot?
Yeah, these are. I mean, you don't need to use Spring Boot to take advantage of Leyden. I'm just using it as a nifty example. Just can't remember the specific command. Yeah. There we go. There we go. Give that a moment to. Okay, I guess I didn't actually skip the test. Hopefully all the tests pass.
I call this Korando stable.
Huh?
Korando stable.
Yeah.
Guess we also it works when you do it live.
Yeah, no kidding. Let's see. Is this skip test? No.
The
Yeah.
S at the start has to be lowercase.
Oh yeah, that's probably
But
it.
it's a test with an S, I think.
Yeah, I believe it is tests. Skip it this time. There we go. Thank you. All right. Sorry about that. All right. So if I was to start this application up, we can see here very conveniently Spring Boot tells you how long it takes the application to start. So it's about 2.4 seconds here, just starting it up as I normally would. So if I go over here and I then restart the application, and so what this is going to do, you can send a command to where once the JVM or once the Spring Boot application starts up, you can tell Spring Boot just to immediately kill it. So that's kind of what I did here. It started up, immediately killed it. And so here we see we built a cache. The caches are somewhat large in size. So it's about 113 megabytes, as we can kind of see here. So they're kind of hefty in size, but they also don't scale too bad. So if I was to do like a simple Hello World application, like it starts at about 90 megabytes. So between like a Hello World application and a Spring Boot microservice, we're only adding about 20 megabytes in size for just doing like a startup of it. So it doesn't scale too crazily, but they're also not necessarily, 500 kilobytes or something like that. So that said, though, if I was to run this application again, though, using the cache I just built, it now starts up in 1.7 seconds. So obviously it's going to be relative based upon the application you're running and whatever might be running in the background. But we can see here with this application, with whatever's happening also on my system at the time, we went from, 2.4 seconds for startup to 1.7 seconds. And so this can also be how you can also think about the training runs. Maybe what you really just care about is improving the startup, in which case your training run could just be literally about starting your application and then killing it, and then taking that cache and then just saying like, hey, yep, all we care about is the startup performance. We don't care the warm up, we're happy with that. So you don't necessarily need to think that we're having to do really complex behavior, because developing a complex training run that simulates production behavior, within your test environment, that could take a certain amount of time, and it may or may not be worth it. So that said, let me go ahead and then do a load against this application. This is a simple OHA tool. All it does is you give it a endpoint to call, and it will just hit that endpoint just endlessly. So with this one, again, without having done any sort of training against the actual load of the application, we did about 7,800 requests within 5 seconds. So if I stop this application again, here again, I will just start the application up, and now I'm going to record this training run. So once again, we see the slower startup again. Once again, I'll hit it with this load where it's going to begin making thousands of calls. And so we see when it's also running in training mode, it doesn't really have too much impact on throughput. Most of the performance impact is going to be on the shutdown here, where I shut this application down again. And at this point, the shutdown takes a bit longer because, of course, it's actually building that cache out. So you're not really having too much of a performance hit from running this in record mode. And so we see here then when running load against it, so before it was about 110 megabytes, now it's just a little under 130 megabytes. So again, it doesn't scale too crazy from doing these things, but now what's included within this cache is the profiles it got from watching this application have some load applied against it. So before we did about 7,800 transactions in about 5 seconds, or it executed about 7,800 requests. Now if I run that again, we will see after 5 seconds, it should be a bit over, so yeah, just under 8,400. So a bit of an improvement when it comes to the responses. Now, it quickly trails off. So if I was to run this for 10 seconds, then, like 10 seconds, it maybe would have done about 20,000 requests without the cache. And then if I was to run this again with it, with the cache, like it maybe would do 20,500. So, and that's just because, we're only getting the benefit of the warm-up. The profiles are being loaded at the very start of the application. So now the JVM immediately knows what it needs to do to improve, or what code it needs to start recompiling to optimize. But again, then that benefit, at least in this very arbitrary scenario, trails off pretty quick. Yes?
So I'm trying to compare this to
Crack. Right?
Yeah.
So crack is taking a snapshot.
Mm-hmm.
This is not taking a snapshot.
Mm-hmm.
So this is like capturing the behavior of the methods. That's the big difference between this and crack.
Yes. Yeah. Exactly. So that's exactly it. So yeah. So I'll go back to what I mentioned before. But yeah, with crack, that's checkpoint return at return, something like that. Where yeah, like I was like, let's say I was to start up my application, and then I would create a in-memory image of your application at this specific state, which would include all that, code compilation and all that stuff. So like what you're kind of starting, so when you then restart the application, you're kind of just restarting that application at that specific state that it was. Whereas this is just kind of recording like some of the key behaviors that it has done. Again, there's some trade-offs between using crack. Like I said, if you're doing like a multi-region deployment, if you were to do like a flash image of that memory in like one region, like US East 1, and then try to start up in US West 1, some of those file path locations could run into some issues. Like that could be one of the trade-offs with there. Of course, that's all overcomable, but at least you don't quite have that issue here with Leyden. And so one of the other nice things is that as also like you still have the full JVM and JIT, which you would still have a crack, but with this you have the full JVM and JIT. And so let's say with that cache, like the training run you made was just not accurate to what it's like in production. You still have the JIT, you still have the full JVM. It can actually fall back. You're like, oh wait, I don't need to load this class, I need to load this class, I'll just load it up on the file system. Oh, this optimization doesn't make any sense. I'll just optimize it based upon what's actually happening right now with the application. So that's one of the benefits. You're not having to give everything up. That said, as you're maybe working with it and you're kind of wanting to get some diagnostics of what's happening, there are a few options right now, and this is something that's going to kind of improve in the future as well. But you can use, that isn't, That's not what I wanted to do. That's what else to do. So one logging command you can pass is xlog AOT. And so what that does is like an alias for the JVM to output at info level all the different AOT commands. And like that's, and along with that, it's like also taking in, if you have experience with CDS, like it also covers all that stuff as well. So yeah, it can kind of tell you how maybe it's using stuff for the cache, or as you're writing out to the cache, like it can give you more extensive output for that. So if I was to do that again here, that's not the correct command. Yeah, that's what to do. Oh, okay. I think that's one. Sorry.
Doesn't like that option.
Yeah, I don't. And it suddenly changed on me. Yeah, okay, that's okay. I don't know why that. Oh, that's right. That's why it's failing. I wasn't using the correct JDK version within that window of my. Yeah, it helps me use the correct JDK version. Okay, there we go. So if I run this again, and if I just shut it down here with that xlog AOT option enabled, you can see that actually provides a bit more output. I know this may be a bit small, but like it can also be, but it can like provide you like a table of like the number of classes it's storing within that cache. Like the kind of like there's a different area in here where it says like how much like training it's done as well. So that could be a way of maybe you're saying like, hold on, like maybe why aren't we getting the performance we were expecting? You know, you can kind of turn on like that setting to kind of compare between different runs to kind of see the results you're seeing. Another one, it is going to be pretty overwhelming to look at. I'll go ahead and warn about that right now. This is a way of viewing what's actually stored in the cache itself. Let me go back here just so I don't. So yeah, it will produce a whole lot of output here about what's all actually in the cache itself. Let's see, whoops, it's not in here. Yeah, it's pretty overwhelming for me to even look at it. I still need to kind of work with the Leyden team on how to properly interpret all what you just saw there. And simple output. Yeah, there we go. That's the one I want. But yeah, you know, here it is, not just in a terminal, but at least in a text editor. But yeah, you know, there is considerable amount of information stored within it. But again, you know, as you get more familiar with it, you can kind of see, like, for example, it shows you which loaders this code is loading from. I believe this is the previous example I showed of like a Hello World looking application. But for example, if I was to do this with like Spring Boot, like it would also show the custom load class loaders that Spring Boot uses as well. So you could be like, hold on, like why is it not getting all the classes? Like, oh, okay, we're not seeing the additional class loaders actually being loaded in there as well. So that can be a way of just like actually, you know, interrogating it. Yeah. So the road ahead, you know, we're very much at the very start of Project Leyden. So some more major updates that at least have a JEP assigned with them. So just a quick thing. So JEPs, that stands for JDK Enhancement Proposal. So whenever there's a somewhat substantial change being made to the JDK, it goes through the JEP process, and that is a way of bringing not notification, but raising awareness about a change coming, a way of also incorporating feedback from the community as well. And then also within it, this isn't one of them, but like the JEP will also give like history and motivation and why this change is being done. There we go. But yeah, so one of them is JEP 516, and this is to allow Leyden to work with all of the 4 default garbage collectors. So right now, Leyden only works with the G1 garbage collector, which is the default garbage collector, and then the parallel and serial garbage collectors. But JEP 516 will allow it to also work with the ZGC garbage collector, which was released back in JDK 16, I believe, and then also got a major update to it in JDK 21. Then another JEP that's currently in draft status is the ahead of time code compilation. So right now it does the method profiling, saying like, hey, okay, these are all the methods that are being actively used, but it's not actually saving the JIT code compilation. This one would obviously do that, so that would be a farther benefit as well. So about a year ago now, the Leyden team, they did a EA release. So obviously as right now there's like the JDK 25 EA release, which is what I'm actually using to demonstrate this project. But also some of these sub-projects like Leyden or Loom as well at one point, they will do EA releases to where it'll be a branch off of the main trunk to where you can kind of get, where they can put all their changes in it and they get feedback from that. So there's still a few things within this branch that's not actually stuff that's been integrated into the main line yet. So you can kind of get a view as to where they're kind of going a bit into the future as well. Also related, and this is probably going to be pretty far down the line. I should probably actually take this off here, but could be something like stable values that we're working on right now. So what a stable value is that, of course we have constants, and so obviously a constant's immutable. It's only set once kind of during the class initialization or instance initialization. But there could be cases where you have a value where you do only want it to be set once, but maybe you don't want to have that to be part of the class or instance initialization. But all the same, when a value like that could be something that could also be cached as well. But again, that's pretty far down the line, just because first we even need to cover class initialization, just because once you start to get into user code, you have to make sure you don't allow the users to do something silly, like maybe you have a seed value. You don't want to store a seed value or certain cryptographic information within the cache, because obviously that should be generated every time at runtime, and then obviously some of the obvious security implications as well. So that's going to be somewhat farther down the line, and maybe it never gets there as well. Some other continued more minor updates that might not be actually at the JEP level. So obviously all this work involves going deep into the JVM internals, particularly on startup and all that stuff. And a lot of times the JDK team, they're finding areas that could be done better. So there's a lot of refactoring work that's being done there. And some of the refactoring work just needs to be done to better support the Leyden as well. So as some of that work is done, it won't be at the JEP level, but it would still provide performance improvements probably in the future as well. Also, as like the frameworks, like I said, the Spring Boot team, Sebastian Deleuze has been often working with the Leyden team. They might also make improvements to their own frameworks to better take advantage of the AOT features. So, that stuff could get better in the future as well. I thought I'd put some updates here, but also like the diagnostic aspect. They're going to continue working to better support that as well, so that you can kind of get a better idea of all the behavior that's going on within your application. But that said, follow-up links is again inside Java and Dev Java. At the start of this year, I released a video where I did a deep dive into JVM startup. It's a very complex task that is also not super well documented, so that was a lot of fun. But in the example, like I just do, the very bare, simple hello world example. And I can't remember offhand, but I think even in the most simple example, when you're starting hello world, you're looking at starting, or like the JVM, like loads and links like 200 some odd classes. Like so 2,000? That's what it was years ago. Yeah, something like that. It's a very shocking amount. And that's just because you get a bunch of observability and a bunch of other stuff that's happening within there. That's also the print line, right? And print line. I mean, so there's a lot of happening during startup. So it just kind of demonstrates a lot of work that happens in there. But kind of getting an understanding of that, you can maybe also get a better appreciation as to what this stuff Leyden is working on. But yeah, with that said, yeah, any questions or?
What's the relation with the raw project?
I mean, it's not too much of a relationship outside of kind of at least some working in some of the same domain areas of improving startup. But yeah, the Graal, that's a separate team. The Graal VM is its own separate implementation of the JVM as well. So yeah, usually, I think there is some communication maybe sometimes between the team, but not a whole lot. It's two separate teams really.
Yes. You mentioned one of the goals is to reduce the time it takes for the application to get to its peak performance. As like hot swapping cache, you have a separate AOT cache for build time, separate AOT cache for like after the application has started ramping up. So like dynamic swapping of caching is something team considering, or you want to have a single AOT cache which gets optimized as application runs?
So yeah, you would only do a single AOT cache, like if you had different cache profiles for like different load states, like chances are it'd probably be a different application or something like that probably. But yeah, you would only have one cache. So at least one area though that does remind me that like the Leyden team is also looking eventually at improving is so like right now, like you need to kill the application for the cache to be created. Like right now we're looking at, or not right now, but at least like one of the things they're hoping to maybe eventually get to is to where you can just have the JVM spit out the cache without having to kill it. I don't know how many people have used JFR here before. But yeah, so like with JFR, like it's an observability tool that's built into the JDK, but you can tell JFR to like spit out data to you without having to kill the application. So I imagine it works somewhat similar like that. Yeah. Yes.
Not about the topic, but how do you make a presentation in GitHub?
Oh, yeah. So what I am doing is using a framework called Reveal.js. And so what I can do is read in markdown files and.
You seem to get this question at every meetup.
Yeah, well, actually, I don't often get that, but it is kind of funny. I got asked twice here, back to back in presentations. But yeah, so it's a framework called Reveal.js, which you can see just right here. JavaScript framework, whatever. But what it can do then is it can read markdown files and then produce the HTML from that. And so like for here, like the two down V's, like you can define it whatever you be, but like the two down V's would just say that go down to the next slide or something like that, or you can have it be whatever for going between right and left. So yeah, it's nice. Obviously it's not pixel perfect like you can do with like PowerPoint. It doesn't have animations as nicely as PowerPoint, so like there are some trade-offs, but overall it's a lot easier, and it's also great that like it's readable, and then it's also like, okay, you can just go to this presentation right here. It's very easy to share the presentations, and then also when I do new presentations, I can just do easy Control-C, Control-V, because like a lot of the intro and the outro is gonna be reused, other than changing a few things around. So yeah, it's pretty nice for that. I do need to do a little more work to make them a little bit prettier. I keep intending to do that, but then other things come up. So, yeah. Awesome. Well, Oh, yeah, we only have 3 minutes left, so perfect. Perfect.
Thanks, Billy.
All right, thank you.
Does anyone here not have an IntelliJ license that wants one or have one that's about to expire?
I'm losing my student license.
Cool.
Oh, yeah, you go.
Email us at info@javasig.com and we'll send you your license. What's your name?
Here you go, Peter.
I'm sorry.
We're running out of people to give IntelliJ license away to.
I know that so often seems to happen, and so many judges like, I have 5 already.
So we were going to do a takeaway. We're going to terminate your license if you want.
Yeah, there you go. Perfect. That's the way to keep them coming back then, right?